Here you will learn how to measure power factor in Simulink. But the interesting thing is there is no ready-made block available in Simulink to measure power factor. So now the question is how to measure power factor in Simulink. So that is what we are going to explore in this video. So let's get started. So now our primary circuit is ready, and in our previous video we have learned how to measure active and reactive power in Simulink, and that measurement we did using two blocks, normal power block and power phasor block. So if you want to explore that, you can check out the previous video from the link given in description or here in I button. So now here we are measuring active and reactive power of the circuit. Now let's run the simulation and observe that this is the active and reactive power that we are measuring. So the yellow one is active power and the blue one is reactive power. Here there is no direct block which can measure power factor in Simulink. So here we'll use whatever we have and we'll get whatever we want. So what do we have right now? Here we have active power and reactive power, and we want power factor. So we can get power factor from this active power and reactive power. Let me show you a small calculation for that. Here this is our active power and the reactive power is 90° to it. And this is the total or apparent power. So in the simulation we are measuring active power and reactive power. The equation for power factor is active power divided by apparent power. And what is the equation for apparent power? Basically the apparent power is S square is equal to active power square plus reactive power square, P square plus Q square. So if we rewrite the equation for power factor, then cos phi is equal to P by S, active by apparent. But what we are measuring? We are not measuring apparent power, but instead we are measuring active power and reactive power. So we'll rewrite this equation as cos phi is equal to P divided by under root P square plus Q square. So this will give us power factor cos phi. So now let's jump back to the simulation. So are you enjoying the simulation journey so far? So now we are going to use one block which is named as FCN. Basically that is function. So we'll take this FCN block, right? Now we'll take one mux. We'll connect this P and we'll connect this Q. So we are combining two signal and giving this to this FCN. Now we'll open this FCN. We'll remove this expression and write our new expression. Here on the screen you can see the equation that we are going to implement over here. The equation is P. So P is actually our U1. Our first signal is P. So we'll write U of 1. That means our first input divided by, now everything is under root. So we'll write SQRT of U1 square plus U2 square and bracket over. So this is the equation for power factor that we are implementing over here, and let's hit OK. So using this equation it will convert this power into power factor. So here our power factor is ready. Now we'll add a display. We'll connect this function's output to the display so that we can observe the output. And now you need to pause for a moment and tell me whatever quantity we are going to observe in this display, that quantity is which? Whether it is cos phi or it is phi. So write the answer in comments below so that I can identify that how much attentive you are in this video. So now it's time to reveal the answer. The quantity we'll observe over here, that will be cos phi, right? That is power factor. So now let's run this, and you can see over here the power factor is 0.92, and over here you can see the active power is 20 watt and reactive power is 10 VAR. Now let me increase the reactive power to 30 VAR. So here you can see the reactive power is more and active power is less. And now let's find out the power factor. Now let's run. So the updated answer is 0.66. So the power factor will reduce when we increase the reactive power. Now from this power factor you can even find out the angle, and to find out the angle from this you have to do this. Let's say A cos. So this A cos just simply does inverse of cos. So the A cos is connected over here. Now we'll take another display, we'll connect it, and now let's run. The angle shows 0.83 around. Okay, so this angle is in radian, so we're supposed to convert it into degree. So let's remove it. So we have added a gain block. Now in order to convert from radian to degree, you're supposed to multiply it with gain of 360 by 2 pi. Okay, now let's run. Oh my god, it's 474. It's not the correct answer. Let me open it. Okay, so this is the mistake that I did. I supposed to make a bracket over here. And now let's run. Okay, so the angle is 48 degree and the power factor is 0.66. Let me change it again. Now I am making reactive power 0. So when the reactive power is 0, what should be the power factor? Any guesses? Write your guesses in comments and we'll see it now. The power factor is unity and the angle is 0. Change it again. And the result is in front of you. So this is how you can measure power factor in Simulink.